Good day, students. I am Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. Today, I am going to deliver a lecture on superconductivity. This is a topic of MSc Final Physics and the paper is fifth. In my previous lectures, what I have discussed, I am today going to give questions on that basis. So for that, I am summarizing what I taught in my previous lectures. For this, what is the definition of superconductivity? Superconductivity means that there is a complete exclusion of electrical resistance in a substance at a very low temperature. Disappearance of resistivity means conductivity becomes infinite. That means superconductors are the materials which possess infinite conductivity. This is a temperature dependent property. This I will discuss in my properties of superconductors. I am going to discuss here 5 properties. That 5 properties are zero electrical resistance, Misner effect, critical temperature, 4th being the critical magnetic field, and 5th is the persistent current. So I am starting my first property, that is zero electrical resistance or infinite conductivity. We know that a superconducting material possesses zero electrical resistance. Resistance is zero, that means its conductivity is infinite. This was first discovered in mercury. When it is cooled below 4 Kelvin, it was found that its resistance drops to 0. That means its conductivity becomes infinite. This temperature at which the transition has occurred, that means for mercury 4 Kelvin, this is the transition temperature. So superconductors have zero resistivity. Now moving over to the second property. This is a very important property, Misner Effect. Misner Effect states that when a superconductor is placed in a magnetic field, then magnetic field lines cannot penetrate inside the superconductor. That means B equal to 0 inside the superconductor. This phenomena is termed as Misner effect. That means there is an expulsion of magnetic field inside the superconductor. By placing a superconductor in a magnetic field, field lines are only outside the superconductor. Inside there is no magnetic lines of forces. What is the third property? Third property is critical temperature, which is also termed as transition temperature. Critical temperature is the temperature at which material transforms from one phase or one state to the another state. What are these two states? These are normal conducting state and other state being the superconducting state. That means at T equal to Tc, there is a transition from normal conducting state to another state which is termed as superconducting state. Now fourth property is critical magnetic field. We have seen that there are two states, normal and superconducting state, and this transition is temperature dependent. This transition is also magnetic field dependent. Now I am placing my superconductor in a magnetic field and I am increasing the strength of magnetic field. It is found that beyond a certain that at critical magnetic field, the superconductivity will change into normal conducting behavior. This magnetic field at which the transition occurs from superconducting state to normal state is called critical magnetic field. This critical magnetic field is also dependent on temperature. Now, what is the next property? The next property is persistent current. I am taking my superconductor and placing it in a magnetic field. Now I am cooling the ring of this superconductor below its critical temperature so that it becomes to a superconducting state, and now I am removing the magnetic field. Then by Lenz's law, we know that magnetic field will be induced in it, and due to the magnetic field, the current will induce in the superconducting ring. And this current is termed as persistent current. Why persistent current? Because this current flow in a superconductor even in the absence of magnetic field. And this current flows in the superconducting ring for a very long time with a very undiminished strength. Now, this was a revision of what I taught in my previous lectures. On this basis, I am giving you some questions. What are the questions? First question is in a superconductivity, the conductivity of material becomes, I am giving 4 options. You have to choose one of among them. In superconductivity, the conductivity of material becomes 0, infinite, finite, or none of these. Now, second question is the temperature at which conductivity of a material becomes infinite. What it is termed as, you have to choose out of these 4 options. Critical temperature, absolute temperature, mean temperature, crystallization temperature. The third question is, the superconducting state is perfectly dash in nature. You have to determine the nature of the superconducting state. Fourth is, in superconductivity, the electrical resistivity of material becomes, you have to find the value of electrical resistance of a material in which state? In superconducting state. Fifth is, the minimum amount of current that can be passed through a superconductor in order to destroy the superconductivity, it is termed as, you have to choose among these 4 options: induced current, critical current, eddy current, or Hall current. The 6th MCQ which I am giving you is, the ideal superconductors exhibit, I am writing 4 effects. Which effect is exhibited by the ideal superconductors? You have to name that effect. Next question is, the transition temperature of mercury. What is the transition temperature of mercury? You have to find out whether it is 1 Kelvin, 1.14, 4.12, or 9.22 Kelvin. 8th question is, a superconducting material on being subjected to critical field change to which state? Whether it is normal, or it remains uninfluenced, or critical conductivity appear, or superconductor which is independent of temperature. 9th question is, you have to find out the properties of superconductor. I am giving you properties. Which among these is the property of superconductor? First is, they are diamagnetic in nature, they have 0 resistivity, they have infinite conductivity, or 4th option is all of these. The last MCQ is, magnetic lines of forces, they cannot penetrate inside the body of superconductor. This phenomena is known as isotope effect, VCS theory, Misner effect, or London theory. I hope you must solve these 10 MCQs as early as possible. In my next lecture, I will discuss these MCQ